Okay, by my watch, we have 1 o'clock Eastern Time, so I think in respect to everyone's schedule, we should get started. I would imagine that a number of people will continue to connect, but we have muted the pings that normally signal their arrival so that we won't know as they arrive that they have, but at some point here in the near future, we will have an assessment of how many people we have on the call, but we did have a large number of registrants. So, like I say, in respect to folks' schedule, we should get started. I'd like to just introduce myself. My name is Matt Kleinhens, and welcome. And I'm at the Ohio Agricultural Research and Development Center in Worcester, Ohio. That's part of the Ohio State University, and that's where I am speaking to you from, along with Stephanie Short and Nicole Wright, both of whom are integral members of the team here at Ohio State. My job over the next 90 minutes is to ensure that you are repaid for the time that you spend on the call, repaid primarily with information and the knowledge that your input is important. So you're welcome to join us going forward as well as we work to help everyone get more from crop biostimulants that share 4 important characteristics, and it's important to keep these in mind as we move forward. First, they contain microbes as an active ingredient, perhaps the active ingredient. Second, they are OMRI listed and used by sustainable organic growers. Third, they are advertised to enhance growth and or crop resistance to stress. And finally, they can be applied to vegetable crops. I recognize that we have people on the line who work with other than vegetable crops. We are confident that the principles and the broad messages that will be shared this afternoon or this morning, wherever your location is, will apply to crops that are not vegetables, but we are emphasizing, at least for the moment, the application of products that fit those criteria to vegetable crops. Before we turn to the business at hand, I would like to cover 6 important points of background. First, please note that you currently cannot be heard. All the callers now are muted. I'm the only one that can be heard at this time. Second, you will remain muted until you push *6 on your device's dialer pad. This will unmute you and allow you to be heard so that you can ask a question or make a comment. Third, when you unmute yourself, please remember that we hope to hear your voice and only your voice, perhaps a minimum amount of background noise. So please push *6 again after making your comment or asking your question, or take steps to ensure that your location is quiet. It is a treat and an opportunity to have so many people on the call today. We hope to hear from as many of you as possible in an orderly and a productive way. So thank you for helping in that regard by remaining muted until you wish to speak up or remain quiet during other times. So on that note, if email works best for you, you can submit a comment or a question to the following email address, which is always active, including during the call. That email address is vegbiostimsferts, that's VEGBIOSTIMSFERTS, vegbiostimsferts @gmail.com. So you're welcome to submit a comment or question by email. We will do our best to process it during the call. If we're unable to do that, we will certainly do our best to process it as soon as possible after the call. And sometimes that involves forwarding it on to an expert that we feel can address it most appropriately. The 5th bit of background is that this call is made possible because of support from the following: USDA Organic Transitions Program, the North Central Region SARE Research and Education Program, and the companies and organizations represented by all the people on the call. We want to acknowledge that support because it is very, very important to us. Finally, you might be wondering who else is on the call. Of course, we can't provide specific information about individuals, but you recall information you shared when you registered. From that, I can say that people on the call, or at least the registrant list, represented 4 countries, more than 20 states, and various universities, biostimulant manufacturers, and individual farm and consultancy businesses. most people being directly involved in vegetable production or crop production in some way, and perhaps especially sustainable organic vegetable production. But as you speak up or email in, please feel free to introduce yourself and to say where you are from and how you come to be interested in this particular category of crop biostimulants. So that completes our background. Remember, to be heard currently, you must push *6 on your dialer pad. Are there any questions before we get to the introductions of our resource people and the topic of the day?
Can they hear us?
So, hearing none, I guess we can proceed with that. Remember, you are currently muted, and unmute yourself by pushing *6 on your device's dialer pad, and that is also true for landline phones also. So for those who participated in our previous conference calls and or who have listened to recordings of them at our so-called Bugs in a Drug webpage, you recall that we covered a wide range of topics describing microbe-containing crop biostimulants, and that we uncovered important questions that will take more time to answer to everyone's satisfaction, especially growers' satisfaction, than we have today. You also recall that the panelists provided important insights and advice, and there's no doubt that the same will be true today and going forward. So along with you, the call-in participants, with your own experience, which we definitely want to hear from today and capitalize on, we have 4 people committed to serving as resource people. In alphabetical order, they are Uta Albrecht of the University of Florida, Mike Austin of Agrinos, John Kemp of Advancing Eco Agriculture, and Joseph Roshko of Mycorrhizal Applications. They are here to help us address the main topic of the day, which is using microbe-containing crop biostimulants most effectively. The emphasis being put on the word use. We want to emphasize tactics and steps and principles that result in applications having the greatest potential to provide an adequate return on investment. So there are many, as you I'm sure know, there are many of these products on the market, but very, very few resources describing how to use them. That is, that describe the process for applying them in great enough detail to result in that greatest chance of an adequate return on investment. Very few resources emphasizing major do's and don'ts in sufficient detail. And not knowing these do's and don'ts may result in poor product performance, which disappoints everyone. It serves no purpose to have a product fail only because it was used incorrectly. Today we look to help by clarifying ways most people either work for or against themselves when they apply an inoculant. So let's get started. And I'll reach out to Mike Austin first. And Mike, I'll just remind you that you need to push *6 to be unmuted. Mike, I know that you've led and conducted many field trials on farms and research stations, and you've worked with many people in the process, folks representing different walks of life. So I'd like to just ask, how about it? What about a trial or an application, but especially a set of applications, in terms of how they are made, makes you confident that it will be that those applications will result in a credible, reliable test of the product's potential? What are the items that stand out most to you?
Okay, well, thank you, Matthew. Can you hear me?
Yeah, can hear you. Thanks.
Okay, good. One of the things I preach from my soapbox when it comes to microbial products, like we have a microbial product in Agrinos we use quite a bit, and is on the market. And you need information from the suppliers on what the appropriate dose rate is. You also need to know and talk to the agronomists at these companies about timing. Timing is critical. And timing is everything, actually. And finally, targeting. Where do you target this microbial product to expect to get the best results? There are a few other things in there, Matt, that, like shelf life, stability of the product, and how long has it been sitting on the shelf. those kind of things also need to be taken into account. But I'll just really talk about, timing, targeting, and dose rate today.
Those are excellent
What I
points.
have found.
Yeah, go ahead.
Go
Sorry.
ahead.
No, go ahead. Sorry.
Oh, what I have found is too much. Less is more in many ways with micro. At least speaking on behalf of our product, as I know it. When I first started 3 years ago, I would think, well, 1 liter per acre or 1 quart per acre is good, then 3 liters has got to be better. Well, my research shows that that's not necessarily the case, but it depends on application. So with high-value specialty crops in greenhouse settings or outdoors with drip irrigation, and you have a tomato crop for tomatoes for the table, you definitely want to be applying your products probably once every 2 or 3 weeks through the drip, alongside any other products you're giving those plants. I understand a lot of organic farmers are here, but there's also conventional farmers in the group too. You need to apply a certain amount every 2 or 3 weeks through the life of that plant, and we're getting with our product generally, Matthew, 8 to 16% yield increases and better quality in things like tomatoes and strawberries.
So Mike, you mentioned
row crop, and we're not really talking about row crops. Then that's where the 1 liter per acre, maybe 2 liters per acre kind of rates kick in. You got to look at then the return on the investment for the farmer, and that's where you work closely with a farmer on expectations and return on investment when they buy these type of products.
So it's an excellent summary. John, if I could, I'll just reach out to you next. Mike mentioned dose rate, timing, and targeting. Mike, I believe by that you mean where's the material put, the placement. So John,
targeting is the rhizosphere, Matthew.
Okay, all right. So John, maybe if we could scrape a bit deeper. It's been my experience that quite a few products have the label on quite a few products is incomplete with respect to those 3 factors. So, especially perhaps if that's the case, John, where would you recommend somebody start with a product that has maybe an incomplete label and they don't have time, or they have been unable to reach the product supplier or manufacturer rep? Are there any items that you would add to Mike's list as the critical factors to consider for a grower when they're applying the material?
There are a few pieces that I would add. Can you hear me clearly, Mike?
Yeah, you're coming through well.
Sorry. Okay, great. There are a few pieces that I would add, perhaps in parallel with what was described earlier in terms of practical application and use. And typically these microbial biostimulants are used either in irrigation systems or at planting. And increasingly, one of the pieces that we're observing with the commercial fruit and vegetable growers that we work with is that they're being used as foliar sprays. And of course, there's different products for different uses, but we've found that there are several factors that are, I would suggest, critical, completely critical for the success, particularly of a foliar spray, that to some degree also transfer to the use of these inoculants in an irrigation system. So I'll just review those very briefly, and then I'll see if I answered your question well. When we're applying microbes, biostimulants, inoculants through a spray system, whether it's soil applied or plant foliage applied, we find that sprayer pressure is very important. In general, just as a kind of a general rule of thumb, we find that anything greater than 55 pounds per square inch results in cell damage to most biology. There are a few exceptions, but that's a really good rule of thumb that we use. Secondly, whenever we want to avoid the use of chlorinated water or any water that contains any other biocides. When we're using the biostimulants as foliar sprays, we find that they generally don't work well when applied to plant foliage when we have air temperatures above about 86 to 89 degrees Fahrenheit. So warmer temperatures, we typically recommend farmers not apply biostimulants as a foliar. And perhaps most importantly of all, never ever dream of tank mixing a microbial biostimulant with something that is intended to kill bacteria, such as a copper application or a sulfur application or some other type of fungicide, because you've just eliminated the potential effectiveness of whatever it is that you had hoped to apply. So all of those are kind of do nots, but then one thing that you can do that we have observed often having a substantial benefit is partnering a synergistic biostimulant, whether that be an enzyme product or a food source, some type of biostimulant that can stimulate the biology that you're actually applying. So those are the major pieces that we look at when we look at spraying microbial biostimulants onto soil or onto plants. And obviously, some of those factors hold true for irrigation systems as well, and others not so much. So those are the major pieces that I would add.
Excellent. I know we have some manufacturers on the line, and we want to get to them as well, for sure. Kind of an open forum discussion, which is what this needs to remain. But Joseph, if I can point to you next, I mean we have the mycorrhizal applications representative. And I know that the first two, Mike and John, they've been approaching the question as I would have hoped, I guess generally, irrespective of bacteria or fungal, I believe, with the possible exception of the biocide comment, but I think it still applies. Joseph, from your standpoint, do you think we need to add anything to the list that's been growing here that currently includes dose rate, timing, targeting, spray or PSI, chlorinated water, high air temperatures, no tank mixing with a biocide, and partnering with another biostimulant? Is there anything that you think is still lacking on that list? Joseph, remember you got to push *6 on your handset or your phone. Joseph, are you with us? Maybe not. Uta, if we could redirect, and maybe Joseph will come back in a moment. Working with the citrus crops that you have, being aware of other reports, do you think that there's an item that's missing on that list so far?
Yeah, well, and I haven't done much with a mycorrhiza, but one thing that always, especially for Florida soils where they're relatively high in phosphorus, from all I can think of, we should probably avoid fertilizers with a high phosphorus content. So that's one of the things. And otherwise, I agree with everything, but from my practical experience here, at least on citrus crops, there's a lot of things that are unfortunately unavoidable that were just pointed out as no-dos, which include, for example, high rates of copper. We have in citrus a problem with citrus bacterial canker, and there's a lot of foliar copper applications, and so our soils are relatively high in copper, so that would be a problem. We also have the problem of we use usually when we use the products, of course, we use the water that's available at the farm in the irrigation canals, and so they're often very high in pH. And of course, although I do really not believe in applying microbial products foliar, especially not in citrus, we generally do have temperatures higher than 86 Fahrenheit in Florida, unfortunately. So most of the applications that we are doing is to the soil via soil trench and since it's really impossible in a commercial environment to do replicated field trials through the commercial drip system or irrigation jets. So we usually apply it with handheld or motorized sprayers.
Excellent perspective. Yes, because we are trying to capture, as large a geographic footprint here as we can with the collective expertise that's on the call, people sharing their observations and experience with regard to what seems to have been important in their work so far, even if it's preliminary. I mean, items to consider, going forward, because the soil types and the cropping conditions have long been topics of discussions on these calls, that being the soil types and conditions that promote or, if you will, suppress the efficacy of these products overall. I'll just put it out to the group that is on the call. Remember, you need to push *6 to be heard at this point. Any other items that have not yet been mentioned that you find to be critical in influencing the success of an application?
Yeah, Matt, this is Joseph.
Okay, yeah, Joseph, go ahead. Speak up if you could, please.
Sorry, I had some issues with *6 earlier. So I think these are very good points that Uta mentioned and the previous resource person, that high level or high concentration of phosphorus fertilization, particularly for mycorrhizae, it's not recommended because that suppresses actually the hyper growth and germination of the mycorrhizal spores and also the root fragments. The other thing that we've been looking at in the last couple of years is actually the drip irrigation, particularly with mycorrhizal products or products that contain mycorrhizal propagules. And since the propagules consist of spores and root fragments, we have to be very careful and read the label what is the propagule size for these products, these soil inoculants, because what we noticed that particularly with drip irrigation, the mesh size in the emitters could be an issue, and when applying these products, because they could actually just clog these irrigation systems, and that could become a major issue for vegetable growers and fruit growers and any other growers as well. The other thing is, I don't remember who mentioned the fungicides. Yeah, together, particularly with mycorrhizal products, soil inoculants, using fungicides together with these inoculants could be an issue, although not all fungicides are detrimental. And at the same time, you have to be careful applying fungicides in the same season, because sometimes you apply foliarly a very harsh chemical, and they could be washed off into the soil, and they could still suppress, let's say, mycorrhizal growth. These suppressions are normally temporarily, but they could impact the level of colonization or their impact on plant growth.
Joseph, can I interrupt real quick and ask if copper-based fungicides are detrimental to mycorrhizal applications? Foliar applied copper-based fungicides.
No.
Okay. I think that might be a question that I know I had. Maybe other people knew the answer already, but
no, that wasn't a problem.
Okay. Excellent. So I know that there was at least one person trying to speak up when I put the general call out before Joseph came on. I'd like to go back to them as well, or anybody would like to add to this list that they think is important for factors to consider when applying an inoculant.
Yeah, this is Dennis Warnicki with Tineo Biologicals.
Excellent. Great to have you, Dennis. Thank you.
You bet. One of the things I want to touch on, we talked about the mycorrhizae and plugging of the drip irrigation systems, but one of the things we have to think of before we get there is the filters, screens, sand media filters, all the different methods of filtering water prior to it going in through the spray equipment or the drip irrigation, and that is critical when we start to talk about this, because we can filter them out before they even get to the drip system or to the plant or to the soil or through the foliar application if we don't pay attention to screen size. And I know with microapply, they generally talk with Dr. Mike was 50 mesh screens on the mycorrhizae, and then we generally say 80 mesh for the biological products. But it's really important that you pay attention to that based on the manufacturer so that you make sure you're getting a good application from the get-go, because that's really where it starts.
So Dennis, that's an excellent point. I'm just furiously writing down some of these notes because these are some of these are ones that I frankly have not considered. I'm embarrassed to say, but I'm learning along with others, it seems. As we look at labels across the whole category, 200 plus products right now that fit the 4 characteristics I mentioned up front. Of course, I have not read every product label thoroughly. My sense, however, is that many do not bring out some of these specifics. Is that your sense also, or I don't want to put you on the spot per se, but I'm struck by the number of specific questions that a grower would want to ask of the label and or the rep, the product rep.
Yeah. And I do find that true. Part of that has to come when you're talking about applications of biologicals. For an example, when you look at our product, 50 grams to the acre, it's a very small bag and a very small label, and based on label requirements, we have to get as much information as we can on there. One of the things that we do is in our box, every box that we ship out comes with an additional information based on mixing and spray application. So there'll be additional information with every product in the box that tells you exactly some of the do's and don'ts of what you should look for when mixing these products. And I don't know if other manufacturers do that, but I'm sure there are that have that additional information for the grower when they receive the product.
Excellent. Supplemental. So supplemental info beyond the label. And not to, of course, not to single any out, but that, we've talked a lot, as people know, about product selection. That's not the topic for today. We don't want to return to that. We may in the future, but product selection could involve completeness of information about the product, right? And that would include, the topics that we're covering today, how to use it. And the more complete that information is, perhaps the more confident the grower has in the return on investment. Okay, others want to comment along the same line as in terms of the do's and don'ts of application. We seem to have a good list. If you'll allow me, I'll run through it very very fast, and then segue onto a question I have, unless others speak up. Do's and don'ts we've heard so far is obviously connecting with the company. Starting us off with, Mike started us off by suggesting we work with the company to understand the dose rate, the timing, and the targeting, the placement. John emphasized the ways in which these products are being applied, including through increasingly large number of applications through foliar. So the sprayer PSI becomes an issue. Chlorinated or water, or any water that contains a biocide in it. Air temperatures exceeding, I would say, 86 to 89 Fahrenheit. Being very careful. Basically, I think, John, you said don't even think about tank mixing with another biocide, but we've had some nuanced follow-up on that. A do to consider would be to include a synergistic biostimulant, which we can get to here in a moment. Uta mentioned the potential for interference created by a high phosphorus fertilizer being applied at the same time, and other normal crop inputs in many systems, including biocides of one sort or another, and the potential for interference through high pH water. We then turn to the discussion of, if you will, propagule size, especially important perhaps for the fungal applicants, fungal inoculants, but not unique to them, and the need for the grower, the user, to know what the propagule size is. as they also look at the filters, screens, and other components of their irrigation system, since so many are being applied through the irrigation water. With the expertise that we have on the line, if we are comfortable with that being a working list, we can move on to other aspects of the application. Any last thoughts on that list? Remember, if you haven't spoken up, or even if you have and you're still muted, you need to hit *6 to speak up. So we do want to hear from others. I'll put out to the group and to the resource people something that does not appear to have come up so far, at least directly, and that is mixing the product with the rooting medium, particularly important in the vegetable transplant production phase. We've heard a bit about soil drenching, but nothing explicit, I think, about the application during the seedling phase. And so maybe going back to Mike's point about timing and targeting, and perhaps even related to that dose rate, do the applications tend to begin very early in the crop cycle? Do they start midway? Does it matter if the crop is a fruiting type crop, so it produces a fruit like a tomato, versus a leafy crop or a potato that doesn't produce a fruit? What are the issues there that come into play in knowing how to use the product or apply the product?
Matt, this is Mike. The best targeting from a microbial standpoint is exactly at that stage in the greenhouse, making plugs. Your ability to get a product down in these plugs and allow that seedling to grow up good and healthy and vigorous, then to be transplanted with either the mycorrhizal product or the microbial product, or maybe even both, which would be a good mix, goes out to the field with that. And so talk about targeting, that's the best time to get this stuff in.
During seedling production, during transplant, what if, okay, so there's an assumption that the inoculation beginning at seedling production will translate into more profit later, especially if those inoculations are continued. Any other follow-up comments or questions to that from the group or our resource people?
Yeah, but most of the growers will get it from a nursery, and the nursery is not necessarily doing this, what you just recommended, or if they're doing it, they'll probably charge a higher price, so there's a lot of issues to be considered.
Yeah.
I know that in the citrus industry, for example, I know there's one nursery that is trying to incorporate the mycorrhizal product, and they just have to charge more for the trees that they deliver, and that may not be taken up very positively by the growers. So, and the same of course, in the vegetable industry. Yeah. And I know the vegetable growers, the few that I've worked with, they add it in the transplant water when they get the seedlings. So.
Good points. We may need to. We'll come back to this. I think it's probably others are seeing a theme emerge, but we don't want to get to that right away. I'd still like to ask if if there are other comments about the application timing and placement, especially around the transplant.
Yeah, Matt, this is John. I have one comment that I would add around transplants. We have worked with many growers who have experimented with adding microbial biostimulants and mycorrhizal fungi when planting seeds this is specifically for annual vegetables, into soilless media, usually peat moss-based media. And we have found a generally positive response. It's very inexpensive application usually because it doesn't take very much product, and we get a very nice plant response. But usually we don't do just that. We will apply some at planting the seed, and then again a second application when transplanting, because what we've discovered is these various bacteria and fungi propagate differently and sometimes much less successfully in peat moss than they do in real soil. So even though we do the applications early at planting, we like to then come back and again do another application, either as a drench of the seedling trays or in the transplant solution, just to make sure that we get another dose, a fresh dose, of a mixed population right at the planting period.
That's an aha moment for me and perhaps others. We have so many commercial vegetable transplants being produced in a peat-based, and perhaps all peat-based medium, that it makes me wonder if we are feeding, and if inoculations begin at that time in a 4 to 6 week window, makes me wonder if we need to feed the microbe properly, because we cannot necessarily assume that the root exudates are going to do the job alone. Is that reasonable?
Well, I would say that is a reasonable consideration, but there's also just the very simple fact that the peat moss substrate is fundamentally different from topsoil, and it actually suppresses some fungi, including some mycorrhizal fungi. So you can get a very skewed bacterial and fungal population, and the product that you apply may be, just as a hypothetical example, perhaps 3 strains out of 12 that were applied of different bacteria might survive, or a couple of strains of mycorrhizae. So we find it valuable to reinoculate just to maintain and to increase diversity.
Reinoculation is adding cost.
Well, I'm saying reinoculation, but in reality, we are applying the inoculant at a full dose for the first time at the moment of transplanting or just prior to transplanting. Because in reality, if you do a seed coating or put on a small amount at seeding, the amount required is incredibly small. I mean, you're treating very, very small volumes of seed and soil usually.
True. Yeah. Good point.
I want to throw something in here. And a brief experience I had here, there are some growers who actually apply some carbon salts in the transplant water together with a microbial product. Mostly it's like some sort of humic or fulvic acid product. And also several growers actually tried as far as applying molasses into the transplant hole.
Right, so that goes to John's point. I think it was number 5. Apply or partner with a synergistic. John, I don't want to speak for you, but it was partner with another synergistic stimulant of some sort. That seems to be in that same category. Am I correct?
Yeah, exactly. It can be humic substances, fulvic substances, carbohydrates, different types of sugars. It can be enzymes. There's seaweed. There's today dozens of different active ingredients on the marketplace that can provide that effect. But in general, we get very positive effects from those.
So I don't know if we've exhausted the seedling production question so much. If there are questions or comments that others would like to offer, this would be a great time to do that.
I'll add one more piece, and then I'll shut up. And that is, this is the moment in time when you can apply the least amount of product and get the greatest economic crop response of almost anything that you can do in the entire crop life. The moment of transplanting, when you have transplant stress, is the moment where products almost invariably give us the greatest economic response. So it's a very important timing and targeting window from our perspective. And now I'll turn it over to others who I'm sure have a lot to contribute.
Thank you, John. Yeah, I believe there was somebody speaking up at the same time as John. Let's hear from them.
It's Joseph, Matt. A couple of comments I'd like to add to confirm, previous comments. That basically, from a grower standpoint, probably the most economic application is, at earlier stage, at seedling stage or transplanting stage. Because what we normally recommend, applying, let's say, fungal inoculants, it's based on actually the plant size or the size of the root zone. So while you can get away with 1 propagule in a transplant tray per cell, at a later stage when you apply, let's say, a drench application, when the plants or tomato plants or whatever other vegetable plants are bigger, we would normally recommend like 5, 10, or even more propagules per plant. So from grower standpoint, that's probably the most economical application. And from biological standpoint, actually that's the best, because for mycorrhizae specifically takes a few weeks for the symbiosis to form. So the earlier you apply, the better you off. So you have more time during the plant growth and development for the mycorrhizae to help the plant and form the symbiosis. And at the same time, we have to consider, because we run into issues with some growers who applied mycorrhizae in crops where, the crop cycle is not that long, very short. Let's say in radish, where, you can harvest within 4 weeks or so, and that time interval is not even enough for the symbiosis to form. So that doesn't make much sense to apply mycorrhizae. So you have to consider at the same time the growth cycle or the development of the plant, how long it is.
Excellent points. And that also kind of overlaps with your point about radish, Joseph, I think overlapped, or short cycling crop, overlaps with some of the conversation that we had around selecting a product and a crop, a good combination. And mycorrhizae on radish may not be as productive a combination as others would be.
Yes.
Right.
Yes, you're
Right.
correct.
Right. Any other comments about application do's and don'ts, particularly as it might apply to relate to timing or placement? That stand out to anybody? Yes, please go ahead.
Yeah, okay.
Go ahead.
Yeah, go ahead.
Dennis again. One more thing I would add to that at Transplant, one of the things we talk about biostimulants and their effect on the plant is reducing stress, as John kind of pointed out. And this is our greatest opportunity to either root dip or through a water wheel in furrow application. We talked about a lot of these plants come to us from a nursery and had not been inoculated in the nursery. So we have an opportunity to put that mycorrhizae or biology directly on the root of that plant at the time of planting, where we're going to get our biggest response, I think, is what we're talking about here. So, root dip, soil inoculation through water wheel is an excellent time to make the most significant difference in the genetic potential of that plant from the very beginning of reducing stress and putting it into the soil.
Excellent point. A water wheel, of course, has no pressure in it, right? So that's that's great. It's an automatic root drench. Yes, follow-up point to that or question?
Matt, I think one of the questions you brought up earlier was, well, if you're doing it early on seedlings, now you're adding more product, it's more expensive. But that's not necessarily the case. The seedling stage, because you're targeting so good, if your recommendation, for instance, is 1 liter per acre in the seedling stage in flat, you can use 30 milliliters. And then when you're going out, somebody was talking about root dipping. Well, your targeting is so good that you do 300 mils in the greenhouse, you do 700 mils in the root tip. There's your 1 liter. So this doesn't necessarily add cost to the product, but what you're doing is really targeting your product, your material, into the root zone where microbes and the mycorrhiza, the VAM mycorrhiza belong. So it doesn't get much better than that.
Sure. Bonnie, I'm not sure if it was you that was intending to speak up earlier, but I wanted to make sure that there was space for you too, if it was indeed you or whoever it might have been a moment ago.
This is Ute. I just wanted to add something from the perspective here in Florida. I think transplant water, applying it at the early stage is critical, but also I think one need to consider what the soil type. In my brief experience here in Florida, we have very sandy soils. There is not much holding capacity of anything. So I'm thinking that a lot of our microbial products just don't even survive after they're applied. So if we want to be successful here, we may consider more continuous reapplication of the product, which may ultimately be not economically feasible.
Tim Coulong at the University of Georgia on a call March 21st was referencing a similar situation with the sandy soils there. I'd like to just follow up to both his comment and yours, Uta, and mention, of course, that gravelly soils would be, perhaps the same situation, and maybe any situation where there's the drainage is very good, very fast, I guess, and the capacity to hold water and maybe even low organic matter soils contributes to the need to reapply. I wonder if folks on the call, especially those who have had a lot of experience working with inoculants on many different soil types, would be able to comment on working with them on heavier soil types, finer textured soil types, more clayey soils. Are there specific concerns there? Silence.
I would, Matt, this is John. I'll be happy to jump in for just a moment. I think in general, our experience has been that these biostimulants do work well on heavier soils as long as there is good aeration. So I think the key piece is compaction. If you have heavier soils, as long as you have good aeration, don't have strong compaction, they still tend to do very well. The moment you introduce compaction and soil compression into that scenario, then performance goes down substantially very quickly.
Good point. It's not just texture alone. It's probably other components of soil health, including the till, especially the till. Any other comments or questions about application do's and don'ts that we're focusing on at the moment, which have been the timing and targeting piece, but there are dosage rate questions. There are interactions with other components of the cropping system, other inputs, even the irrigation water, pH. These are items we have not yet explored as thoroughly as we have the timing and targeting pieces that were first named early on in the conversation.
I have a question.
Yeah, please. Let's hold on one second, please, with a question. Yeah, go ahead.
Yeah, this is Margaret Lloyd. I'm a farm advisor for University of California Cooperative Extension. And I was wondering about temperature, soil temperature. Here in California, air temperatures for us in the Central Valley in the north range from as cold as 27 to over 100 degree days. And I'm wondering, and we transplant kind of throughout the year, any month. So I'm wondering about soil temperatures and maybe air temperatures, but thinking about that aspect of application of these biological products.
Great question, Margaret. Thank you. I'd like to put the question, have, if you will, in a somewhat orderly fashion here, have our manufacturer reps and other university folks address it one at a time, and maybe start with Mike at Agrinos. Remember, you'll need to push star 6 if you're muted.
Yeah, I'm back in. Margaret, we do a lot of work in California, actually, and temperature is critical for the delivery of the product. Certainly, you don't want to leave it on the surface of the soil and hope to water it in or anything. To me, the best approach with a microbial product is to work it into the soil, either at planting or 30 days later, spiking it 2 inches over, whatever. You want to get that soil to microbial contact and get it down into the rhizosphere. You can go down 2 inches if you can. And the temperature in the soil is radically different compared to at the surface. One of the things we care about a lot is cold temperatures and microbes in soils coming out of winter and spring. I think the cold temperatures make those microbes just sit there. They don't multiply. They don't vibrate, if you will. Kind of like that's why we refrigerate food. But the really high temperatures, over 100 degrees Fahrenheit, if you work that product into the soil, you should be okay.
John, any or Joseph next?
Yeah, I'll jump in quickly. High soil temperatures are a major concern in our experience, particularly and I know this is a discussion for fruit and vegetable crops, but when you have bare soil, exposed soil that is directly exposed to sunlight, it's fairly easy for surface soil temperatures in the top 2 inches or so to go all the way up to 130 to 140 degrees Fahrenheit in both in California and throughout the Midwest. And so obviously we know that many enzymes degrade at 130 degrees Fahrenheit. And so I think the point that was mentioned, that Mike mentioned earlier, it is important to get these materials into the soil deep enough that they are protected from high temperatures. And in some cases, in a few extreme environments, that may not even be possible. I haven't seen that very often, but I have seen it a few times. So I think it is important to pay attention to, and the good news is that it's easy to measure. You can take a thermometer and get it into the soil and pretty quickly find out where it is at various depth levels.
Good point. Joseph, before turning to you, I'll just toss out, and obviously this is just thinking out loud. Maybe I should temper myself, but I suspect that exposure to sunlight may also itself may be detrimental from a radiation energy standpoint if these microbes are not necessarily quote designed to tolerate high levels of light. Light itself may be a problem beyond the temperature. But Joseph, what might you have to say about temperature? Soil temperature, that is, specifically.
From mycorrhizal standpoint that we have the most experience with is basically we never really experienced any particular issues because the mycorrhizal propagules, the fungal propagules, are normally very resilient, and what we recommend is to apply when the plants are present. And when the plants are present, that indicates, so if the plants can survive, the mycorrhizae can survive. So they normally live in symbiosis, and the mycorrhizae cannot function, cannot grow by itself without the plant present, or the root exudates from the plant. And if the plant can survive, we normally say the mycorrhiza can survive. So we never really had any issues. Although sometimes growers want to make sure that they apply the product before planting. That could be an issue if the temperatures are so extreme. We normally say that up to 140 degrees, it's safe to apply mycorrhizae, and this would be, the high extreme. Regarding the low extremes, I could say pretty much the same what I just said for the high temperatures, because so mycorrhiza in nature can overwinter during the winter, in the soil where the temperature is pretty low. So we don't really have any issues. And as I said earlier, these propagules, the spores, and the colonized root fragments are very resilient.
Attending the conference in Miami in November of 2017, I was struck by one presentation speaking to the temperature sensitivity of a type of rhizobial inoculant. I'm not a microbiologist, everyone knows this, and I repeatedly show that in different ways. It's my assumption that each of the microbial components of an inoculant have a temperature sensitivity. They have a range over which they grow optimally. There's an optimal range. It's also my understanding that these ranges are not well known for most microbial inoculants. Therefore, I think this question about soil temperature, air temperature, is still open. While we have the excellent input that we've heard so far, projecting far into the future, we may actually have more data on the temperature sensitivity of various inoculants, prominent ones, and therefore be better positioned to know that if it's springtime in the northern latitudes, is not the right time to apply inoculant A, for example. So I think that's just perhaps an example of the information yet to come that would make our use of these products that much more reliable. Any other questions or comments along these lines specific to the optimization of application?
Yeah, this is Jim Porterfield. Can you hear me?
Yes, please speak up. Thank you.
Okay. Yeah. I did have one question back to the foliar side of things on timing. Is there a difference in terms of when you apply, whether the sap is rising or the sap is falling?
Great question.
Matt, this is John. I'll be happy to jump in. I would say that the inoculants, the biostimulants that are being applied are often phytosanitary bacteria, sometimes compost teas and other less engineered products, but generally products containing microbes that are intended to live on the leaf surface. And the key for those is they have a synergistic relationship with the plant where they are consuming small amounts of sugars and amino acids that plants release through the leaf surface, very similar as they do to root exudates. So we find that in terms of leaf establishment of viable colonies of these disease-suppressive organisms, we get the best success when we apply products in the late evening. So I don't know how that corresponds with the direction of sap flow, but generally we find that evening applications are the most effective.
Taking timing to another level. It's not even about crop stage. It may be about time of day or other unit of time. Great question. I honestly don't know how to. I would defer to others on that. Any other questions specific to the do's and don'ts of successful application?
This is Joe from University of California.
Yeah, go ahead, please.
I do have a question for our growers, especially for tomato, because most of our transplants are provided by commercial greenhouses before growers can put them in the field. So that means they lose the chance to mixing the rooting media. But the timing they have probably, I guess, would be the time before they move the plants into the field, which means a root bath or root drench. So I do have a question about when soaking the trays into this microbial solution. Just two questions. One, what time or how long do they have to be soaked? 5 minutes, 10 minutes, 20 minutes, 30 minutes? Or, and the second question is, does the water have to be stirred to make sure the microbes mixing the water or suspending the water to be mobile enough that can reach every cells of the tray?
I'll defer to Dennis or Mike or John or Uta, whomever else on the call that has worked with familiar with obviously a situation where we have large number of transplants in their trays, and we're trying to drench them, soak the medium with a microbial inoculant solution. Some of the specifics of that process, and Jung mentioned two. The duration of exposure.
Dennis.
Go ahead, Dennis. Yeah, go ahead, Dennis.
Generally, my recommendation on that is I like in the greenhouse scenario as a soil drench, I would love to see tank agitation as a drench with a wand to keep everything stirred, and partly because it goes back to what John talked about, is I like to see a food source added with that, and a lot of those are suspendable products. They don't really go into solution, especially if we look at the humic substances. So generally I'm recommending tank agitation on that soil drench. If we just do a light soil drench prior to take them out to the field, and then we go out there with the inoculum through the water wheel, or we just leave the soil drench through the trays to do the application, that works fine. If we're doing a dip type scenario, generally I do recommend that you stir that tank once in a while as you're going through doing the dipping. And then, when we talk about tree roots, we say up to 12 hours when we're doing bare root trees. Obviously, that's not practical in the row crop industry. So just a general dip, saturation, let it drain over the tank, and then go to field application is what we recommend.
Very good, Dennis.
This is
Thank
John.
you.
I'll weigh in here as well. What's most common for the large-scale commercial growers that we work with is, as Dennis described, they would blend usually mycorrhizae or whatever inoculants they're using into a tank, inject it. Would still be in the greenhouse or perhaps on the grower's site just before they go to the field, and inject it through a dosatron or whatever nutrient injector they are using, and just simply water it in with their last watering. So it's not a question of, in my opinion, it's not a question of soaking or really getting the need to have it exposed for an extended period. Just making sure that you have a good uniform application, uniform coverage with watering, and it's easy and done.
Excellent. Other questions? Yeah, go ahead, Mike.
I agree with the last two comments exactly. And I think for a microbe anyway, I'm not talking mycorrhizae, but for microbe, once you're done drenching those trays of seedlings, I think the last speaker said, and then water it in. And that's exactly what you should do, because if you're going to take those trays then outdoors and stage them for transplanting, they could be sitting out in direct sunlight for the entire day. And the UV light and heat, and Matthew, you brought this up, could degrade the microbial makeup. So if you water it in, you're driving those microbes down into a protective layer of peat or sphagnum moss or sunshine mix number 4. But I think just do your business as usual, get your dose on there, and water it in, and you should be good to go.
Very good. Were there other comments or questions about these do's and don'ts, this aspect of successful application?
Actually, I have a question.
Please, yeah.
So Chris Bush from Ohio. I know we talked about chlorine in the water. Is there a thing with like the pH being too high or too low, or for it not working?
So pH sensitivity for the manufacturers in the group, or others with experience here, pH sensitivity for inoculants, particularly as we talk about the importance of water, in delivery. What about the chemistry of that water? The only comment I recall hearing earlier was that potentially a high pH may be detrimental. But can we put a finer point on this?
Yeah, either extreme on pHs can restrict the microbial community as inoculums that we put into that soil environment. So a lot of times if we have a high pH water, I may recommend that we add like an apple cider vinegar or something to drop that pH down, more between that probably 6 to 7.5 if we can. 5.5 to probably 8 is going to be fine. We also have to understand how long that microbial community is going to be in that inoculum before putting them into the soil environment, because once they hit that soil environment, they're going to change that profile, and that profile will change very quickly. But that is something to look at when we start to look at tank mixing inoculums, especially if it's going to be an extended period of time. And again, John talked about buffering them with a food source or a carbon source, and anything we can do to that will protect them a little bit, not only from the pH, but also from the sunlight that you have talked about a little bit as we take them out of that environment. So it creates a protection around them and gives them a home.
That's a great point. I appreciate the question about pH because, and Dennis, your comment about the separating the pH or the chemistry of the water, the overall chemistry of the water that it might be mixed in the tank, from the chemistry that will then develop when it's in contact with the rooting medium, which is going back to a comment earlier about peat-based for some vegetable transplants anyway, has very little buffering capacity. So, I think as we drill deeper on this, we look at the interactions between individual components of the system for sure, the water, the rooting medium, the physical substrate, and maybe other inputs that we have as well, and they all appear to have to work together. But straight out pH question seems to be 5 to 8 is acceptable, if I have that right, Dennis.
That would be correct, and obviously the closer we get to the optimum range of soil pH, the better off we're going to be.
Sure. Any other questions or comments specific to the delivery, specifically the delivery? Yeah, go ahead.
Yeah, one comment. You mentioned sunlight and ultraviolet. It's been a bit intriguing for us, but we have actually noticed an improvement in performance when we deliberately use dark materials in the solution that's being applied with a sprayer. So if we're spraying on an inoculant onto the soil, if we darken the tank mix with, say, humic substances or with molasses or something like that, we seem to get a better response. And we suspect that might be because of ultraviolet protection in the spray tank itself, and possibly even after it's applied for a short period.
Interesting. That may not necessarily mean that we paint our water tanks black, so prevent that and then heat the water up. But there's a happy medium in there somewhere, right?
Yeah, it doesn't take much.
Right.
It doesn't take much at all.
So, what's the group's feeling? Have we exhausted the questions and certainly the practical take-home input around the timing, targeting, and maybe even water chemistry and root medium chemistry components, and that we should look at other aspects, or do we need to explore this further with a question or additional input? Some of the other ones appeared to be a bit self-explanatory, like foliar sprays, pressure in the tank or in the line, filters and screens for propagule size, and so forth. But maybe we need to look at them carefully as well.
I actually have a quick question. When foliar spraying, would it be beneficial to add something to the mix to make it stick better onto the plants?
In general, yes.
And so a surface sticker, what kind of product are we talking about?
It's just a general base.
Yeah, no, I was
to add to help with.
Right, that was directed to
stick better onto the plants.
Sure, that was directed to John. What kind of sticker? I guess. Are there examples?
This is going to sound overly simplistic, but considering the context that we're working, or we're asked to speak directly to organic growers, the two that we use and recommend the most often that deliver the most consistent performance are simply sugar and vegetable oil. The combination of those two seems to provide a very effective spreader sticker that causes the entire spray solution to have a high point of deliquescence and stay liquid on the leaf surface and stay stable on the leaf surface for an extended period.
Okay.
I have something. This is Ute. I have a grower here who swears on using chitosan as a sticker. Not only because it sticks so well, but also it has some other. He uses it on its organic tomatoes pretty much in every spray application, and he's very excited about it. It may have other properties as a biostimulant.
Chitosan is fascinating because it is also an immune elicitor. That's a great idea.
But I haven't, since it's cherry tomatoes, I really haven't had a chance to do a replicated experiment. It's a little complicated to measure yield on this crop. So, but I'm very intrigued by this to investigate any further, and that may be a good opportunity together with the microbes. And I know there's one person here who actually insists, he has his own small company. He insists on adding chitosan to his microbial applications into the soil and together with molasses also. So he calls this a soil a symphony kind of treatment.
Sure. No, I mean, I appreciate John's direction to reference to the need to speak to specifically to sustainable organic growers. That is absolutely the case. At the same time, we do have a wide range of audience today and on all the calls, and a wide range of audience for the information at large, because most people recognize that solid principles cut across systems. The specifics, like an OMRI-approved material versus not, may change, but the principles hold. And so for those that are on the call that don't work with vegetable crops or don't necessarily even focus on sustainable organic systems, but have a strong interest in these products and using them, I wonder if foliar application, going forward, if foliar application will be important to them. And so the idea of, a spreader sticker, the timing and so on, all the things that we've been talking about will still have a lot of meaning to them, but they're going to have to adapt to their system. So organic or not, we need a spreader sticker perhaps for foliar applications if they're going to be made successfully.
Well, they do work without, but as with many materials, they tend to work better with. And I would just say, in general, avoid. We see the best results and the best responses with non-ionic surfactants and the spreader stickers that would be associated with those non-ionic surfactants.
Good point. So I'd like to just hit the pause button real quick as we enter the last 15-20 minutes of our conversation, and just offer a point of view in case it is useful, and then we can transition to other topics as needed. But on March 21st, we had a similar conversation all about selecting a product from the many that are available, either one or a small number of products, and we started by recognizing the large number of products that are available and the large diversity, the high amount of diversity that those products represent in terms of their composition, microbial composition, but also their formulations, powders and the like, different forms. So in that process, we were essentially working to help the user, the grower, and or their advisor funnel the many choices down to a manageable set of a smaller number of choices. So it was a funneling process. From many, we need to identify a smaller number in order to make progress. Today, it seems like it has been somewhat the reverse. Assuming that we have a product or a small number of products that are interesting to us, now we're exploding in a different way. We're examining all of the factors that come into play in using it successfully, creating the situation where the product itself is not the limitation, avoiding the situation where the user is the limitation. Because we've heard time and again, including I and others have heard time and again that a product is fine. You're abusing it and you're using it wrong, and therefore you're not seeing its full potential. And so today's conversation is around removing the grower from as a limitation, removing the step, whoever's using it, removing the person applying the material or the user from the equation as a source of limitation. Okay, and then squarely focusing on the product, so what we see is the product's true performance potential. And by my count, we have in the neighborhood of 14 factors to consider. If I'm keeping track, you might have a slightly different list, but my list has roughly 14 items on it, from dosage rate all the way back to soil temperature. With that in mind, I guess I would invite us to spend a few minutes prioritizing those items. I know that many will want to say, well, look, they're all important. If you take one out, the whole system crumbles down. I can accept that, but I also want to, for the sake of the grower or the person who's hoping to advise them well. If we had our own personal list, which ones are most important, I think, maybe the answer has already been clear. Mike, you named dose rate, timing, and targeting. John said, oh, I agree, but let me add 5 more. And then Uta said, well, those are great ideas. Let me add a few more still. And then Dennis chimed in with a few more. Are they all equally important, or if a grower or a grower advisor encounters a label that is not so clear on these points, and they search around and they don't find the answer right away, where do they start in terms of rank ordering the factors that are going to determine their success? Especially for those that are new to using biostimulants, or after conversations like these really want to rethink their approach. Are there any that stand out, or do we want to just reaffirm what we've already said?
That's Matt. This is John. I'll perhaps kick off. It's a challenging question to answer right off the top of my head, but I would suggest that there are a number of pieces which have been identified, some that Uta identified, and some of those pieces that I spoke about, and what Dennis spoke about regarding mesh size and screen size, that there are a number of pieces which each one individually has the capacity to eliminate any chance for success. So if you put on a microbial biostimulant, but you run with 100 mesh screens and at 100 pounds of pressure, you're not going to have any chance of success whatsoever. So there are a number of pieces I would say are absolutely fundamental that you cannot negotiate on.
Okay, so
then there are some pieces that might limit your success somewhat, but you might still have some potential for success.
Fair point. So it's a fair point. So let me rephrase the question. To those that have studied this situation closely, and perhaps over a large number of growers, what are the factors that stand out as the most common sources of problem of the ones that we've listed? Like, oh yeah, I'll pick on Mike. Mike says I've tried to work with 20 university researchers, and 18 of them have always managed to screw up the timing or whatever. Are there issues that stand of the ones we've listed that stand out as the most common that people here on the call or those who listen to it later would want to recognize as the most common sources of failure?
Yeah, this is Uta. I think for the mycorrhiza products, applying it together with a fertilizer that contains high levels of phosphorus is probably a major problem. Not knowing for a grower, not being aware of this.
Fair enough. Good point. Any others that stand out from those that have looked at this situation carefully? And I personally have not. I mean, obviously, my team and I are trying to develop that level of familiarity through experiences working with growers in Ohio and other states. But I can't sit here right now and say, well, I think the most common reasons for failure are blank. I tend to think that in some cases they've selected the wrong product and crop combination. They begin by the problem begins at product selection. So right out of the gate, I don't care if they apply it perfectly, they don't have a winning combination, and we heard an example of that with mycorrhizae and radish. Mycorrhizae and brassica crops might be another. So there's a selection component. But then if we have a theoretically productive combination of product and crop, I now wonder what are the most common mistakes made at application or use.
Matt, this is Mike. I'll just say that when I do research or I work with distributors or farmers, I try to base any kind of work around the equipment that they have on hand. and you'll be surprised. There's a lot of farmers that don't have up-to-date equipment that could benefit from our product.
A lot of researchers too. I just thought I would throw that in there.
And a lot of universities. You're absolutely right. And so, you know, for me, it's always, how can I still get this product into the soil? And you have to be unique, because if you don't, you will not get the kind of results you hope to get in what if it's research or on-farm type of work. So to me, it's always, what is the equipment on hand, and how can we use it to leverage our products onto these crops?
So, Mike, if I could rephrase, it sounds like you're referring to the incorporation aspect, separate from the typing, separate from the dose, separate from this and that. It's the incorporation component. Am I representing that correctly?
Yes, exactly. Especially with the living organism components of biostimulants.
Okay, so we have Uta mentioned applying a mycorrhizal with high phosphorus fertilizer. That is within the general umbrella, if you will, of co-inputs, if I could use that term. Inputs that are used alongside with, in addition to, at the same time as a biostimulant. If they are incompatible, then obviously the potential for efficacy goes down. Mike mentioned the incorporation component. Okay, look, you can have everything set up perfectly well. You've got the right crop and microbe combination, but if you don't incorporate it properly and probably at the right time, you break down. What other missteps do we want to highlight at this point in the conversation for the benefit of people who will want to take this input and run with it?
This is Dave in Ohio. Hello?
Yes, Dave. Yeah, please. Hello.
I don't think you can minimize the variable of water chemistry. We've, in mixing product in the past, we've erred on the side of caution, used RO water, reverse osmosis, because we have very hard well water here, which is high alkalinity.
Good point. So, we had that whole part of the conversation around water chemistry, and you've taken the step of actually using a separate source of water to, I'm assuming, make your inoculant drench or what have you. But you can't do that for your irrigation water and so on, but you can at least do it for the preparation of the inoculant. Am I right?
That's correct. That was a controlled situation that we did for your field test last year.
Right. Yeah. So Dave is reminding us that we can't minimize water chemistry. Any other factors that are habitual missteps on the part of growers, if you will?
This is Uta. I think reapplication of the product and not just doing a one-time application in the transplant water and then think the microbes will mysteriously, magically all cure all your problems. So I think reapplication is important too, not just once.
So it's the reverse of what Mike said earlier, at least initially. Mike, you were talking about...
Soils, that is.
Yeah, right.
But again, it depends on the specific situation, what is more limiting, or the first speaker said, it depends on you have to, one factor may be limiting and the other thing following is not really important anymore. I think you have to identify that for your specific situation. And I think in our soils here, it is probably to be recommended to apply it more than just in the transplant water.
So in that case, Uta, they would be exaggerating the potential for a single application to be of a single application, perhaps especially in the way that the microbes will multiply and then have their effect, right? I mean, they're exaggerating it's almost like they're expecting it to work like an herbicide or something along those lines.
Yeah.
Okay. So thinking about the product, if you will, incorrectly, forgetting for the moment that it's living and it might need to be nurtured and maybe more reapplied.
Well, the problem is, I mean, it goes probably a little further than this discussion. I'm working with a soil microbiologist here, and we're doing some sequencing of some bioinformatics to even see what happens with the microbes. We always assume they live and survive, but that may not necessarily be the case, you know. I mean, that's a whole other issue. Are they even alive when you get the product? How long do they survive once we apply them? And so that's another issue that we're trying to look into. So that's why I think just putting it in the transplant water may not resolve or may not accomplish what you want to accomplish, at least not here.
Well said. Fascinating stuff, and I agree with you. I mean, we have the same questions here, obviously different climate and different situation, but we wonder, for example, if applications made in high tunnel settings in the fall and spring are worth it. Okay.
Yeah, that's the other thing.
Right.
We have even identified just different locations on different farms. I compared one like a higher input farm, more nutrients, more herbicides and such things, compared with a lower input farm. And we're seeing just microbial differences in the soil just by location. I think these are the major, actually more so than the application did not lead to any changes, but the soil community was completely different in these two different locations, just based on general management or soil that is available at the site.
Well said.
So it gets very complicated, yeah.
Sure. This is a theme that's emerging. No, one needs to be take a lot into account when considering the use of these products. Anything else that stands out that we want to highlight as a potential misstep for people to avoid when they apply an inoculant or begin to use one as a general rule, whether it's bacterial or fungal or mixed? We've heard 3 excellent reminders. Okay, let me. I know that we're drawing close to the end of our scheduled time, just a couple of minutes away, and want to acknowledge that we should wrap up cleanly, well, if you will, and not just take it right to the end and have to wrap up real quickly. I'd like to just say, as to provide some context, and for those that are familiar with these numbers, I do want to be corrected if I misspeak. In our first call on March 21st, we were told that across the whole spectrum of microbial inoculants, it is reasonable to expect them, a good one, to result in a increase in yield on the order of 6%, roughly 30% of the time. Now, I know those numbers change based on who you speak with and who you read and the individual situation. But we emphasized at that point that these are products so far, and I will welcome being corrected. These are products that so far do not have the track record of working really well every time. So they are to be thought of differently. They are to be evaluated differently, if you will. But today's discussion around applying them, using them well, to me, from my vantage point, is focused on those numbers. How can we, what is required to increase one or both of them? Can we get more products to work more often and to work at a higher level? Meaning, by work I mean provide a greater return on investment or a greater yield potential? It really is about, I think, those two words, or those two numbers. How many times and how many trials do you actually get a measurable response? And what is that measurable response? And is it worth the inoculation? So, in as much as the user would be, again, a source of limitation in that, we wanted to try to remove them today by developing the kind of input that we've all heard. In our third conference call of the season, next in May, it is at the Bugs and Drug website. There's still opportunity to register and so on. In the third conference call, we'll attempt to address okay, we've selected a product, we have used the product, now let's assess how to evaluate, or just to talk about how to evaluate the efficacy of the product. And we're delighted to have some excellent resource people committed to that, but we welcome all types of experience for both its comments and its questions. So please do consider joining us in May for that discussion. But for now, unless there are any final words, I would entertain last-minute questions or comments.
I have one comment that I'll add, Matt, just as a general overview, something to think about. The last 2 weeks, I've begun hosting a podcast, regenerativeagriculturepodcast.com. I'll shamelessly plug that for a moment. I had Matt on as one of the initial guests. And in one of the initial episodes, I interviewed Gabe Brown, who's a very successful farmer from North Dakota. And when I asked Gabe about what is the one key thing that has really made a difference on his farm, I was quite surprised by his response. He said a number of years ago, a USDA microbiologist, USDA at the time, Dr. Chris Nichols, who's currently the head of research for Rodale, was on his farm and said, you will never have soils that reach their full biological potential and release all the nutrients your crops need as long as you continue to apply synthetic fertilizers. So Gabe started experimenting, and over a several-year period, he discontinued the use of synthetic fertilizers completely. And today, he has a large farm, I think 1,400 acres, that is extremely successful, high-yielding crops with no synthetic inputs, 100% based on having good soil biology. So that is, to me, that is an ideal to strive for and something to work towards. And it gave me a new appreciation for the potential impact that we might underestimate of synthetic fertilizers. So I found that kind of hit me really hard and gave me a lot to think about, and I wanted to pass that on.
Appreciate that, John. We are certainly experiencing the age of the microbe, if you will. Certainly in agriculture, we are experiencing a bit of that. And so whether it is at in replacement of synthetic fertilizer or in addition to, it's clear that we need to know more about soil biology, and it's also clear that we need to know more about these inoculants, these biostimulants that we're using to supplement soil biology or root zone biology, and the interactions thereof, especially the ones that Uta mentioned, for example. So it's just been delightful to share the time with you today, and I hope to hear from you again. I hope that you can join us for the third call, add your expertise there. And as always, if you have, we are always interested in constructive criticism for how we go about our business here in terms of helping people to select, use, and evaluate these products more effectively. So don't be a stranger. Make sure that your comments and ideas are heard, and good luck on what you do. Because I know spring, for some of us anyway, appears to be, well, I think the comment earlier from Tom in Minnesota was that we won't have a spring. That's probably right. We're going to go straight into the summer season. Regardless, good luck to you, and talk with you next time.